Okay, anyway. Hopefully it just does it. Guys, I'm flying in the dark here. Okay, so, ladies and gentlemen, a really quick rule that I want you guys to understand, or just kind of remember, okay? So, let's say 2 to the x, let's just call it a to the x, okay? I can say that it is equivalent to e to the x natural log of a. I know. And you're thinking maybe, why is this true? Okay? So, let's just look at this. What are we allowed to do with that x in this natural log? We could make it a what? We could make it a, right? So that means this is actually equal to e natural log of a to the x. And that's why, what do e and natural log actually do to each other? They cancel out. But we're going to use this form today. Okay, we're going to use this form to help us understand why the derivative is the way it is. Okay, so what I need you to understand, 2 to the x is a to the x, like it has the same form, right? But we're going to use this to help us understand why the derivative is how it turns out to be. Okay, so we're going to rewrite f of x as e to the x natural log of 2. Are you guys with me so far? Okay. Now, we're going to go ahead and take a derivative using our base, like our derivative rules from e, right? So, f prime of x is equal to, well, what's the derivative of x natural log of 2? Ooh, it's just natural log of 2. Yeah, natural log of 2 is a number. Okay. Times just that original function, right? That is technically the derivative. But if we kind of go backwards, we say f prime of x is equal to natural log of 2 times e to the natural log of 2 to the x. What cancels out here? The natural log and the e. So f prime of x is equal to natural log of 2 times 2 to the x. This is what we're actually doing today. And this is the reason for it. Okay? So what I'm trying to tell you guys, okay?
So that final equation is what?
This is our answer. Yeah. So you're all like, I don't understand why we're getting a natural log of 2 times 2 to the x, right? If we use this rule and we use the derivative of e, this is how we get to that shortcut. This is why it works. Okay? But technically, what I want you guys to understand, and this is what you're going to use today, is that if f of u is equal to a to the u, f prime of u is equal to d dx of u times the natural log of a times a to the u. You're all like, why? Okay? You're probably thinking why. There's a lot going on there. U is your exponent. Can you guys understand that? So what's our exponent over here? X. What's the derivative of x? 1. That's why we didn't see it down here. Okay. What's a in this problem? 2. Here's natural log of 2 times the original problem. Okay. Yes, Brendan.
So you said you have right there d dx, d du in this case? Or?
Well, what is u in terms of? U will be in terms of x.
Got it.
I'm just using this as the general form. Does that make sense?
Yeah.
Okay. All right. So, ladies and gentlemen, let's try this with an actual problem. Let's just kind of go through this. So, example 2. So, f of x is just going to equal 3 to the x. So, as I look at this, f prime of x is equal to the derivative of x in this case, times, let's go to the next part, what's my base? So 3 is my base, so I'm going to do the natural log of 3, right? Times the original, which is 3 to the x. Let's go through and simplify if I can. Derivative of x is just 1, so it ends up being natural log of 3 times 3 to the x. We okay? Yeah? I'm trying. Okay, so example 2, or example 3. I retract my statement. Example 3. Okay, so f of x is equal to 2 to the 3x. Okay, let's just go through this rule. F prime of x is equal to d dx of your exponent times the natural log of my base, which happens to be 2 times the original function. Is there anything I can simplify in here? Yeah, d dx. What's the derivative of 3 to the x? 3. So I get 3 natural log of 2 times 2 to the 3x. Just so you know, some people might not leave it at that. You guys are going to be like, Miss Seaman, it doesn't match. I know. So what might happen is I might make this 3a what? An exponent and make it 2 to the third, which happens to be 8. So I could also write natural log of 8 times 2 to the 3x. Okay. Look out for some of those tricks on your homework. That might happen as well. So using log rules, I can make this 3n exponent. So it'd be 2 to the third. 2 to the third happens to be equivalent to 8. Okay? All right. So, ladies and gentlemen, can we go to example number 4? Trying to stay within my recordable region here. No, Manny. Okay. So, oh, you guys are going to be angry. Okay, but that's all right.
Yay, angry.
You're going to think that it looks nothing like what we're doing. Woo!
It doesn't.
It really does it.
Log A.
I turned it the wrong way. Okay.
What's the base?
I say we don't do it.
So, I have log base 3 of x.
Gotcha.
Okay. What do you mean I got to rearrange it? Be more specific. Do you remember what this means? I know Miss Matthew, I believe, used it a lot if you had her.
Oh, it's 3 to the x.
It's not 3 to the x.
3 to the y equals x.
It's natural log 3 to the power of x?
Not quite.
To
Okay.
the y equals
So guys, this can also be arranged into natural log of x all over natural log of 3. Okay.
I don't know.
What?
She did a lot.
Okay.
But
Maybe for the other hour.
She might have done log base 10 of x over log base 10 of 3 as well. Okay.
That makes more sense.
So the reason I'm using natural log is because we know how to do what with this?
quotient.
No. Well, you could. But do we know how to take a derivative of natural log? Yeah. But you're all like, oh, what's the derivative of natural log of 3? Guys, don't even think
Natural
about
log
that.
of
1 over
3.
3.
Natural log of
Natural log of 3 is a what? Is a number. So we don't have to take a derivative. We're going to treat it as a coefficient. Okay? So y is still equal to 1 over natural log of 3 times natural log of x. This can be treated as a coefficient. So please do so. So the only thing I really have to worry about is taking the derivative of natural log x. Natural log x says to take the derivative of your x and put it over your original, right? So y prime is 1 over natural log of 3, because that's just the coefficient, times, what's the derivative of x? That's my numerator, all over the original, which is just x. And that can be your answer. Okay? You guys okay?
So we just leave the natural log of
It's
3
just a
as
number.
just a number.
It's just a number. It's like pi. It's like radical 2.
Could we
Just
do-
leave it alone.
Could we do 1 over x natural log of 3?
We could. We actually could do 1 over natural log 3 to the x.
Okay.
Oh.
Okay? They're all the same. All right, example 5. And if you're Manny right now, you're thinking, what the heck's going on? So log base 10, and you guys asked for it, cosine of x. Okay? You did ask for it. You asked for it. But guys, let's use the same rule. And if you're trying to remember, I can change any log into a natural log. Okay? So I'm going to rewrite it as y equals, does anybody have an idea? Like, try and piece together, what did I do from here to here?
X over natural log 10.
Mm-hmm. Okay. You guys okay? Is there a coefficient there?
Yes.
What is it?
1 over natural log 10.
1 over natural log 10. Okay. So if you need that side step, 1 over natural log 10. I don't have to worry about that. Times natural log cosine of x. Okay. Now, we don't have to worry about that first part. That natural log cosine of x we do. So if we're going to write y prime, what is the derivative of cosine x? Thank you for not knowing that. Derivative of cosine x? Negative sine x.
We should have gone with the flow.
Okay. All over what? Cosine x. Now, you may or may not leave it like that. I probably would not have that because what is negative sine over cosine? Negative tan. So I probably am going to have like y prime equals negative tan x over natural log of 10. Okay? Yeah, one more for today.
And then you would just leave it left out.
Yeah, why not? I mean, it kind of looks ugly, but who cares?
That's true.
Right?
That's what my mom said when I was born.
Woo! That's rough. So apparently not a face a mother could look. Okay.
Wait, moms are supposed to love their kids?
Just remember you
I've
did
been
that
doing
one
this wrong.
time when you were trying to get a rose to somebody and your mom made you fight with and you were super scared.
Oh, yes, I did.
Okay.
I was like, dang.
So, ladies and gentlemen, this is the last one I do want to talk about. So I have log base 10 in parentheses x squared minus 1 all over x.
Oh my.
What change?
Someone say it.
Chain rule.
Nope. Log rule! What log rule do you want to use?
Oh, yeah.
Well, yeah, the quotient kind of like if we're dividing, what am I allowed to do?
Subtraction.
We're allowed to split them up and subtract. Yes, let's absolutely do that.
What are we talking about?
So log base, just watch.
Did I?
He was going with the flow. Peer
It
pressure,
was
guys.
peer pressure, guys.
Okay, there it is. So you have your numerator, x squared minus 1 minus the log of x. This makes my life way easier. Can we all agree? Okay, so let's go ahead and rearrange because I don't know how to do log base 10, but I can switch everything out into
Natural log.
natural logs. So natural log of what for that first one? X squared minus 1 all over natural log of 10. We're okay? Minus
Natural log x.
all over natural log of 10.
Oh, I know what natural log.
Does anybody have anything super, super genius they want to tell me about?
Combine them.
You can pull out
You
natural
could.
log 10 from both terms.
Yeah, if we pull out 1 over natural log 10 from both of them, I don't have to worry about that fraction. You guys see what I'm talking about? But it's not, I don't know if I would use the word cancel out per se. But it's now a coefficient, right? So now I can just worry about taking these derivatives individually. Okay? Does that make sense to us? Okay. So as I look at this, if I do f prime of x, I still have that coefficient 1 over natural log of 10. Now do these derivatives separately. What's the derivative of x squared minus 1? 2x all over x squared minus 1. Minus derivative of x is just 1, and then, yeah, it will be over x. And yes, you may leave it like that. That is fine. Okay. Okay. Siemens done. Seaman out.